Good morning, everybody. Thank you for attending. I'd like to introduce Stephen Pearson from Principal FAE from Microchip. He's a Principal Field Applications Engineer. He supports FPGA and security applications in multiple market segments. He's also chair of the IOTSF Security Foundation, which is one of our networks at TechWorks. Security Assurance Framework Working Group, which provides a broad set of product security guidance to aid manufacturers to meet product cyber regulatory needs. Brilliant. Over to you, Ian.
That sounds brilliant. That one I wrote it. Okay. Good morning. It's going to be a fairly quick go this because I'm going to try and cover a lot of material, and we've got 20 minutes. You ready? Okay. Let's cover this then. Let's see if this works. We're not. There we go. Right. First things first. Legal disclaimer. I am not a lawyer. Okay. We are talking about law. So we put this in because this is an engineering interpretation of what is law. Okay. The final arbiter is going to be a lawyer or somebody with specific legal training. Okay. Which is not me. But most of the lawyers don't understand this, so it's fine because it's technical. All right. So let's have a look at what we're going to cover. So EU CRA, if you haven't heard about it, is actually law today. It becomes enacted in a few years' time. We'll go through that in detail. So we're going to cover a little bit about the basics of what CRA is, how I place products in the market, and what does it mean? What is that? The implications of it, and what does it extend to? And you remember that it's Europe. Europe is a bunch of different laws that are some CRA, some product law, some product liability law. So there's lots of different things that come together about my product going to market. A little bit about conformance classes and what does that mean. We'll talk a little bit about the essential requirements, obligations, how long the timeline, and then this question of does it affect me in my design, which is kind of the crucial part we're after. All right, so lots to look at here. Too many words. There are other screens I've noticed that are closer to. All right, so CRA essentially covers what we call a product with digital elements. Okay, what does that mean? All right, so it's got some level of compute, it's got some level of intelligence, it runs something, be it hardware or software, and I place that on a product in the market. Okay, so it covers a lot of things. We'll go into that in more detail. We do it by what we call a risk-based assessment. So that means I look at the context in which the product is going to be used in the market and exactly how my connected interfaces work, and we work out what I have to comply with exactly. But it doesn't mean I can go, oh, well, I've decided that my super interconnected always-on product can be run as though it's not there. Because they'll find that one. Or if they don't, one of your competitors will tell them. Okay, that's covering happens well. Okay. It's covering every market at the moment except medical, automotive, maritime, mil-aero, and national security, because they already have their own parallel cyber requirements. So we're talking about consumer in the main, industrial, and then compute, all those kind of things. So everything that's left over basically doesn't have it. Ultimately, what we're trying to do is to improve the product security of a product on the market, including resilience to attack, and then its robustness and reliability if attacked. Okay, so there's lots and lots of words that come around as to how that comes about. And the whole game is to increase from where we are today the posture, what we call the security posture of a product, to increase its capabilities in the marketplace. That's the main thing that we're after. It's going to be implemented by what they call the essential requirements. It's a very broad set of statements, and this is what you're going to do the risk assessment against. And there are all requirements are required in all conformance categories, okay, to a lesser degree based on your risk assessment. Right? And then there's a lot of things that hang around and talk about. And the whole part of it then is to do this mantra of secure by design, secure by default. So that means think about security from the outset, and we'll talk about that near the end. Make sure it's designed with security in mind all the way through, and that the default configuration in the market is secure, which allows the user to remove things if they want to, and it's their choice, but you placed a secure products on the market. The obligations land on what we call the economic operators. So that would be the manufacturer, if they're placing it on the market, or their importer or distributor, if they're placing it into the EU market. Right? This means that anything that's coming in from out the rest of the world into the European market by some means, somebody has to take responsibility for its placement. And therefore, the chain that goes backwards on that one is that they then have to know what the vendors put in, and they then have to ask the vendor who made the board, and they come to us, and somebody goes to the software vendor, and it goes back down the chain until you get rid of the problems that you've got potentially on the board through the risk assessment. You have to have a vulnerability management system in place, and that means that if a problem is discovered in something that you're using, or something is found directly on your product, it can be reported to you. Okay, so if you have a product on sale in the UK, you should already have this in place, and we know most people don't. Okay, so we should have this under current UK law to have a vulnerability reporting process, right? Lots of people still don't. They will come and get you soon, just to give you an idea. They get a year's leeway from April and a bit longer, but then we'll start ramping up. And that's to ensure that products placed in the market are meeting regulations, and also that when you get an issue, it's reported in a timely manner. We'll go through those in detail. You have to think about the support of the product, right? So once your product's placed onto the market, from the day you stop selling it or you end of life that product, there's a support criteria of 5 years from that point onwards, right? Today it's end of life, see ya. All right, so it has a big difference on what you do. It does require a new CE mark, and there are significant penalties. Okay, so 15%, 15 million euros, or 2.5% of revenue, and remember that's per infringement. That's the fun part of that one. Okay, anyone to leave now and stop making products? Okay, right. So what's in scope? All products digital elements are made available on the market. We'll go into that one. Hardware, software, as we said, where the intended purpose or reasonably foreseeable use of which includes a direct or indirect, right, so a connection. So how you connect it, at some point in time, if it meets a data connection or the internet in some way, shape, or form, then it comes in scope. All right. Logical or physical to a device or network. So if I directly connect it to a network, obviously that's the worst case because it's a physically direct connection. Or if I do a serial connection through a PC, which is connected to a network or some other device, okay, comes into scope. So essentially, out of scope, well, if it's no connectivity, it's standalone, and I've got a simple on-off interface which doesn't have a protocol, crucially, because then becomes a data connection, then it's out of scope. But that doesn't say don't have any product security, okay? Because there's still other things that you need to do at board level to prevent access to IP and such like. Right, it's a sensible thing you should do, which you would use. If it is in scope, well, that comes under, I've got a wireless or wired connection, which is directly connected. I've got a wireless or wired connection, which is indirect. So wireless indirect is because I'm going to use a gateway, but it's wireless, therefore anybody can see it with the relevant tool. Okay. And a USB stick. Okay. Anybody want to go back to about, I don't know, about 15 years ago, isn't it? Something like about 15 years ago, little place in, bombed it just a few weeks ago. So that's where it all started. So that's the nebulous of this, is a USB stick into a secure environment. Okay, that's part of the reason it's all there.
But so in this definition, the USB stick is being considered as a connection.
Indirect data connection.
Oh,
yeah. Because I can place something malicious onto the product through a USB stick.
Even though that was completely behind the
gap.
Yeah.
Right. But it's a method in. So why do you think IT departments turn off your USB? Okay, so you can't just plug every thumb drive in the planet in, which is a pain in the bum as an engineer, but that's the reason, because it's a way of getting malicious product into something else, right? So it's in place. Obviously, it's got a cloud connection. Now, if it's a pure web interface with no connectivity control, out of scope, not a problem. App-based UI that controls something, absolutely in scope. And then if it has to be updated, or if it can be updated, it must be. Right. So if I've got a purely ROM-based product and there's no way on earth it can be updated, it's quite difficult to. There's no mechanism for it, but that's part of your risk assessment. All right. So that's sort of what's in scope, to give you an idea that if you're now looking at how do I take all the connections off my product and make it dumb to make life easy, but I can't now sell it because nobody wants it because it's a connected product. Terrible process. Right. Let's talk about the placing on the market then. So I've got a product, I need to place it on the market. What's really important about this to understand, this is not CRA, this is general European product law. And what it basically states is the date at which I place an individual item, really important. So I can't claim type approval. I can't claim that we want this product's already on the market. Yeah, that product is, but the one you build isn't. So that individually serialized item, kind of important. The day that goes on the market, it has to conform with the regulations in place at the point of time it was placed on the market. Okay. Now, if you place it into a distribution channel, that's technically placed on the market. It might not get used for 3 years, 4 years later, right? But the rules were in place the day it was placed on the market. Okay. If you place it directly with the consumer, it's straight into market and it's in use and it's in first use. Once it's been used, then essentially it's free after that because it's on the market already. You're not replacing it on the market, so it can go through and get updated in low standards. But the product technically was on the market at that point. Okay, so that's really important. But this whole thing of it's about individual items. It's about no inheritance or no historic inheritance of type or serial number is crucial, and it's performed by the manufacturer or importer. So whoever is the entity who places that item on the European market. So Amazon, for instance, have got a lot to do because they're effectively the distributor, right? So I don't know how they're going to get around it, but that's how it ends up. Okay, up from that one. Let's talk about conformance categories there. So under the way that this is defined for CRA, there are 4 conformance categories. Most products will land in what we call default category, right? So if you don't have a specific product named on the list in the upper categories, then you're in default. Okay. Default still means, as I said earlier, you have to meet all of the essential requirements and all of the product requirements based on your risk assessment. Okay, so you've got to categorize that and look at it. But it means that you can place it on the market based on the EU, for the way the products have to be placed in the EU market through their scheme. It means you can do it through self-assessment. Okay. Now, what I'd probably say is that most people won't know how to self-assess it properly. Most won't, some won't care. Some who care because it matters to their business will care. And you're probably going to need to engage with a test house for at least 1 cycle, maybe 2, just so you perfect your internal mechanism, right? Because there's a lot to go at. And part of it is because of the continual assessment requirements, which means you have to have a mechanism inside your company to keep on top of that constant update of the threat market when you're testing the product to place it on the market. What was good today is not going to be good in 3 years' time. All right, the world will have changed. So you have to keep that constantly updated, right? And the test houses have to do that to be able to sign it off. Right, so if it's in an upper category, then different things come into place. So if it's important class 1, then there is you can do it through against the harmonized European standard, which we're in the middle of writing. Not that the CRA is kind of tripping over itself in any way, and it's not fully ready to release, but
FPGA is listed there in the class 1.
I'll go over that in a sec. Yeah, go on.
Does that mean the FPGA is a class 1 or any product with an FPGA?
Okay, I'll explain that in a sec. Yes, I'll go over that in a second. So effectively, if you are in an important class 1, you can do it through but again, a self-assessment with a harmonized standard. Okay, and anything beyond that is through usually third party or some other standard which has got some level of third party assessment against it. But what is in those categories is ever decreasing in product type and the amount of security that's needed. And generally, you'll be using one of those products to do something, but you won't have to certify it. Right. So to explain your point, we've called out microprocessor, microcontroller, FPGAs, and tamper resistant and smart cards because that's kind of what we make. Okay. FPGAs in particular because of this one. So the FPGA itself, so what we make and our competitors make, has to be assessed against what will become the harmonized standard when it's written. Okay. A bit late starting by about 6 months because I've only just formed the working group for it. And so it will come under this category when it's done, but that's our job. Okay. Your end product, which is what you assess, can inherit any category of product. Okay. But if your product is not in one of the upper categories, you're assessing a default. Okay. So,
does that mean if our product uses an FPGA and the bit string changes, that would change the classification?
if your bit string changes, it wouldn't change the classification, no, because the FPGA silicon itself would have been pre-assessed. The bit stream, oh, this is the bit I tried to avoid on this. Bit stream is technically software, right? Up until the point it's logic in the part, it's software. It's a whole avenue we didn't want to go down because there's a big discussion over it right now. But until that point, treat it as software. There's a slide on it later. All right. So does that help answer the question? Cool. All right. So CRA specifically itself, what's behind it? There are lots of requirements in there. The darker blue colours are things that are business processes. Okay, so these are things that are around it, but not necessarily the product itself. So I have to have in place the ability to manage and maintain an SBOM. What's an SBOM? You know.
Bill of materials.
Yay! Excellent. Right, software bill of materials. How you create one is fun, to say the least, and it changes everything about the way software's been developed, and they hate it. You have to have this continuous compliance in place because the threat landscape never changes. It's continuously evolving. You have to keep up to date with it. You have to test regularly. You will need to do threat modeling and risk assessment. How many people have done threat modeling before? That's part of 2. So in this industry, basically not, in percentage terms, right? Yeah, that's the challenge that we've got. Doing a proper threat model is hard because the industry doesn't know how to do it either, because they've done it for fintech and for websites and for things that are not a silicon product or a hard product. They've not done it before in that way. It's very different what's got to be done. You have to have updates and you have to have a vulnerability management process. The lighter colors are specific product requirements. Okay. The only real one that's coming out as mandatory in the current way the harmonized standards are being written is you must release the market with no known exploitable vulnerabilities. Now that's good because they put the word known exploitable in, where it just said no vulnerabilities originally, and we went, that's really not going to work. So no known exploitable vulnerabilities, and that, think about it. I'm writing software. I go out to market. I go and look at the CVEs. I find out what's currently going to affect the product. When I start looking at the product with my threat and risk assessment, I look at what its ability to meet the requirements of the market. Can I do it with guaranteed error-free silicon? Not a hope in hell's chance. No matter how much we do, because A, it takes 3 to 4 years to get the silicon to market, and B, we haven't got the regulations yet. So we can't just start making silicon that's at that level. Okay, it's a bit of a conundrum we're in. So for the initial instance with devices getting made, it's a best fit, the best we can get. There will be products out there, and equally, think of how many products are on the market. You can't redesign them all in the next 2 years and get them back on the market with known good error-free silicon that doesn't fully exist yet, and never will, because somebody will find something somewhere. Right? Nearly every device has got a glitch attack or it leaks information because it's impossibly difficult to create when you want it for less than $1. Yeah, you know, industry problems. Industry problems. You guys don't care. You just want to buy it. That's fine. I have to do skill by design default. I need to do secure updates in place. I have all mechanisms for these. Some of these I can, depending on the product, I can go through my risk assessment, my evaluation, and come up with valid reasons why the product I am placing on the market may not need to have that feature. And that's usually because I've mitigated it by passing it up to the system level. Okay. But you have to go through the risk assessment and you have to state all of that clearly to the person going to use it in your use case and everything else. Okay. It's a lot to get through, because a lot of these things have to be written.
So is there a formal method to do the risk assessment, like in a safety assessment, like FPGA or something like that?
No.
Or is that...
No, there is. I'm in the middle of writing it at the moment for our company. There isn't specifically, and when you talk to, I have had long discussions with Adam Shostak. If you know him or heard of him, he's the guy who's Mr. Threat Modeling, if you like, from Microsoft. We had a long discussion on this one, and they went, "Well, it's quite a challenge, isn't it?" So I think the result we came to, because nobody in that industry knows what to do. Okay, there isn't at the moment. The nearest thing is there's a thing called a TARA, threat and risk assessment, within the automotive standards in ISO 21434, but it just says do one. It's perform a threat and risk. Like, okay, how? Okay, so there's a lot of work to work out on this one. So watch that space. Is that, yeah, it's coming.
Where's this going to come from? From
The EU will have something. So one of the models, one of the standards will have some detail on it. But I can't remember which one it is off the top of my head. They are coming up with something, but it still won't be a formal method. Right. So there is going to be a little bit of understanding it, understanding how threat modeling works. It's not so simple. Once you've got through a few of them, a lot of things start to follow because you've got your knowledge base built up and you know what to do and people get trained. But yeah, in the industry, it's pretty difficult because very few people have done them before. And the fintech stuff doesn't necessarily fully apply in all cases because we've got to look at board level problems, at issues around, I've got a key on a device. When does it leak? How do I give it away? Does it matter under which circumstance?
But then also that when you open up this to open source hardware, like in a RISC-V.
RISC-V is an instruction set, not hardware, remember? Okay, everybody's implementation of RISC-V is different because it's only an instruction set. Okay, right, so a couple of crucial other points because we're getting pushed for time. I must protect the availability, authenticity, integrity, and confidentiality of sensitive or important data function. Mouthful? Okay, think about what it means. Otherwise, it's deemed a severe vulnerability. I must fix it. So my view is this is a catch-all that says if my product isn't up to spec and it can't protect the data and the integrity of the product, I have to make it up to, it drags all current products in. Along with be placed on the product market, placed on the product guidelines, because my current product, when I place it on the market, when the rules are enforced, has to meet the rules on the day it was placed, not today's rules. So current product has to be brought into spec. Okay. Think about that one and the amount of work that's now got to be done to survive. It's a biggie. Okay. And then of course the risk assessment, which we've got to do. Talk about that one. Reporting obligations, very, very critical. If you have an incident, you have to notify the enforcement body in Europe or your local country, wherever it happens to be, because they're looking for patterns. Am I seeing 100,000 products being exploited in the same way? Right. You don't see that. You only see your one company, but they're looking at the worldwide picture all the time. So you have to tell them within 24 hours, I've seen something. 24 hours of you being notified or becoming understanding there's an exploit. And that's usually because you found out because your software system has found out you've got a CV on your product. All right. It's currently being exploited in the marketplace. So you've got to be aware of it, let the system do it. I have to tell them what I'm going to do about it within 72 hours. So we found it. Something's happening, we don't know what yet. 72 hours later, this appears to be the problem. Right. Now think about that, 72 hours in a company.
Unplug it.
It's not quite going to work, Pete, sorry. And then a final report to them 14 days after you've fixed it. So there's no defined period in which you have to fix it if it's a basic vulnerability. If it's a severe incident, going back to it's affecting the authenticity, so somebody can exploit the product completely. Okay, I can get past secure boot and all those things. I have to have it fixed within a month. It's impossible for silicon.
So what's the difference between actively exploited and the ability or the chance of it being exploited? Sometimes there's a vulnerability. Let's say you're doing silicon tests and you realize, okay,
it's probability time. Okay, so it's part of your risk assessment and it's probability and it's your EPSS score and all the things you have to look at and going. It's a really, really major problem if it's done. But to do it, I've got to be at the product. I've got to do this. I've got to do this, so they can exploit one board at a time. Versus a network attack where I can take up every single one of your products and it's dead easy to do. Right, that's a big problem. Right, so high probability, very easy to do versus low probability of actually achieving it, and massive if they do because you lose the keys, for instance. So those critical products on that conformance list. Thank you. The critical products on the conformance list get tested in a lab for that for 6 months to a year. Okay, to death to try and extract the keys. So that's why all that testing becomes on the burden of the vendors. Okay, so these are all very important dates. Right, when does it have to be done by? It came into law on my birthday, yay, last year, so it's already law. Okay, but the enforcement is in 36 months from then. So 11th of December 27, products have to be compliant by. Okay, now think about that from how I do it. You're going to have pointer doesn't. Great, doesn't look at the screen. It's not going to get absorbed by the screen. Okay, so you're going to be able to deliver it. You've got to get to the test house, and you've got to be able to do your internal testing to be able to take it to test. You're going to bring everything forward a good 6 months from that already. Okay, we've lost 6 months because it's now like 7 months. Okay, so we're now just about here. So our design time has suddenly shrunk for something we've never done before. I'm not sure how to do, and actually we don't actually have the rules yet from the EU on what to do because they haven't all been written, and they don't come out until at the earliest the back end of this year, sometime next year. So to say this is an impossible task is mission impossible. It's a challenge, but ultimately there are things that we can do up front, right? There are bits that we can work out what to do, and that's what we've got to try and work out and get in place. All right, last bit then. I'm going to get kicked off. Very simple diagram of what to do. So I have an in-scope product, determine the category. That tells me what I've got to test to, how I test it. Perform my risk assessment as the very first thing you do. Because I'm going to design a product. Therefore, I need to know what I'm designing it against. What have I got to test for? Do my secure by design. Create my SBOM. And that also includes FPGA and ASIC software, because it's software when it's on a computer and it's code. Right? We've tried to do this. Go and stand in front of a jury and try and explain software to them. And they'll go, oh, text in a file. And you go, yeah. Okay. HDL text in a file and C text in a file. Yeah. And a bitstream is a binary, right? Until it's logically in the silicon and running, and then it's different. Right? The rules apply there. Have I found everything that I need to do? Make sure I do some pen testing, penetration testing if you don't know how to do it. Another new great skill to learn. Place on the market, and then I'm into my test cycle. So I have to keep testing the product and keeping it up to speed because it's on the market to make sure it's not being affected by vulnerabilities. If it is, go back and look at my TARA again, fix my discovery, release patch, and at the end of the point when I release it, then I have to do a series of things to help the product be living in the market space. All right, so does it affect an FPGA-based design? Person says no. I'll have to go back over it again. Right, yeah, absolutely. If you've got an in-scope product that you've got comms in, it does. So it's going to have lots of requirements that come in from a product process testing, support, and maintenance, which is different to what we do today. Okay, so it's going to change a bit, slightly, about how businesses create products. All right, it's very different. It's a big shift. We're going to bring lots of new things in threat modeling, risk analysis, SBOMs, all these new things that are going to get brought in. And there's this long-term support and continuous compliance requirement, okay, because I've got to keep support patches in place over the long term. All right, so be aware of that. And the key thing to remember is that the person who signs the DOC to say this product complies is signing a legal document. If it doesn't comply, it's fraud. Just so they're aware of that. Okay, because that's a different EU law. Well, it's law everywhere in reality because it's a legal document. All right, so comes into force in December 27. It has an absolutely massive impact on how we price a product on the market and how it has to work in the world. The cyber aspects of designs are definitely changing how we're going to design a product. We have to take it into account up front. And so, yes, the time to engage was about 6 months ago to a year. But now, definitely, if you've not heard of it. All right, thank you. I think we're just about squeezed in.